Welcome back to 3 Inquisitive Kids. This is Contest 5 of Math Olympiad 2022 to 2023 Division E contests. In case this is your first time watching our series or our channel, we cover all sorts of math topics from our own courses to our competition course to Math Olympiad past problems review courses such as this. So these are some practice problems you can use as preparation for future Math Olympiad contests. So again, there's Division E for elementary school and Division M for middle school. And this is a math competition for students, I believe, either grades 4 or 5 to grade 6. You don't need to have any extra math classes in order to solve these problems. These are all solvable using the math that you learn in the classroom. But this isn't what you expect because it is a math competition. And what makes it harder than you may expect is that it's not about how much math you can solve at once. It's about how cleverly you can think about problems and in an out-of-the-box way. So let's dive into these 5 questions. The first one is find the following sum. So here we have this equation right here, and I'll read it aloud. 525,252 plus 52,525 plus 5,252 plus 525 plus 52 plus 5. Now, obviously, you see a pattern, and it's alternating between 5s and 2s. Here, you can pause the video and try to solve all 5 of these questions first before we start going over the answers. All right, anyways, for this question, there's not much strategy that you can do with it. It's just addition. But you have to really make sure that you don't make a silly mistake while doing it because by 4th grade and 5th grade, you definitely already know how to add multi-digit numbers. So let's start with the units digit. We have 2 plus 5 plus 2 plus 5 plus 2 plus 5, which is 3 times 7, which is 21. So we'll leave the 1 in the units place and carry that 2 up. Here we see that it's also 3 pairs of 7, which is, again, 21. 2 plus 2 plus 5 plus 2 plus 5. Now 4 plus 5 is 9. 9 plus 7 is equal to 16. So we can write 16 right there and carry the 1. 1 plus 5 plus 2 plus 5. That's 13. Right through here, we carry the 1, which gives us 5 and then 8. So our final answer for this first one would be 583,611. And this is our final answer. This may be what you get on your first try, but when you're doing a contest, you have 30 minutes to complete it. And if you do have time afterwards, I strongly recommend you to come back to the first problem and really check. And by checking, lots of students may just skip the checking part of the process by just going over their solution, just looking at it, and then saying, oh, nothing changed. Well, what I suggest you to do is that's not really checking your answer because you're going the exact same path to get to that destination. Checking it is taking a different path to try to see if you will get to that exact same destination. So you could use a different way of thinking or maybe split the numbers up your second time checking your answer. Now let's move on to 5b. When the expression 2 times 4 times 5 times 8 times 25 times 125 is written as a whole number, otherwise known as simplified, how many zeros does that whole number have? So it's basically saying the product of this expression, how many zeros does it have? What number do you have to multiply in order to get another 0 or in order to get another place value? That number is always 10 or a multiple of 10. So 10s, 100s, 1000s. So here, we're just trying to see how many of those we have. And this is multiplication, so it gets big very quick. As you do more and more of these problems, you'll start to have some visual pairs, multiplication pairs, that you should immediately know your answers to. So these are some basic facts that you need to do. So one of these should be 2 times 5. Of course you know 2 times 5. That's equal to 10. 2 other facts you should know is 4 times 25 and 8 times 125. These are all respectively 100 and 1000. So these are some base 10 multiplication facts that you need to know by sight. So if you do know these, then it should be pretty easy for you to solve this expression. But if you don't, or you're still working on it, it's okay. All you have to do is stay patient and think about which numbers added together would group more nicely together. We just went over those 3 facts, so we're just going to use the facts to help us solve. We first see 2 times 5. 2 times 5 is equal to 10. So I'll cross them off to show that I've already used them. And then in the workspace, I'll write 10 times. Now what's another math fact that we can use? Remember, they don't have to be always next to each other. That's 4 and 25, which is 100. So we can times 100. And our final fact is 8 and 125, and we get 1000. So after multiplying, we just have a 1 followed by the number of 0. So 1, 2, 3, 4, 5, 6. That would be 1 million. 1 followed by 3 zeros. So 1 million would be the simplified version of this expression. Now let's go back into the question and see what it's asking for. It's asking for how many zeros does that whole number have. So we can't just write 1 million. That's not the answer. Having 1 million zeros behind a 1, that would be a big, big number. We're going to count the number of zeros, which is 6, and our final answer for 5B would be 6. Okay, so something else I want to go over before moving on. So when you're solving Math Olympiad, it does not require you to put in the units. Okay, so you don't have to say 6 zeros. All you have to do is put that number, the numerical part of your answer, into the answer box. Now let's move on to 5C. At the Grub Shrub, the following orders were placed: 3 burgers and 6 fries, which cost $30 in total. 3 burgers and 2 fries, which cost $18 in total. Now we're trying to find the cost in dollars of 2 burgers and 3 fries. In order to solve this question, we first need to find the individual cost of 1 burger and 1 fry. So there's 2 ways. One is the elementary school method and one is the middle school method. If you're someone who went ahead and you already know some algebra, or you're just starting pre-algebra, maybe you're in early middle school, then you may have some idea of how to solve this. But before that, I'm going to go over the elementary school method because most of the people who are taking this test are likely to be in late elementary school. So here is how you can do this. 3 burgers and 6 fries, $30 in total. 3 burgers and 2 fries, which cost $18 in total. Now I want you to think about the differences between these 2 orders. What was different? What was different was the decrease from 6 fries to 2 fries. 6 fries from the first order to 2 fries. And how did this affect the price of the meal? Well, if you take away 4 fries, then you have to pay $12 less. The cost of the meals went from $30 to $18. So that's significantly cheaper. If we subtract 4 fries, it's the same as taking away $12. And we don't have to talk about the burger part because 3 burgers stayed the same. It was first 3 burgers and then 3 burgers. So now we see that the amount of 4 fries is the same as $12. So if 4 fries equal $12, then what does 1 fry equal? 1 fry is equal to $3. So 1 fry is equal to $3. Now what about burgers? How do we find the individual cost of 1 burger? Well, now we already know the individual cost of a fry, right? So let's, for example, take this second order. Let's take that as an example. 3 burgers plus 2 fries, which we know each cost $3, cost $18 in total. So what would be the total money spent on fries for this meal? So 3 burgers plus $6 is equal to $18. If we subtract $6 from 18, we get $12. So 3 burgers is equal to $12. Then what does 1 burger equal? Then 1 burger, I'll just write burg for burger, is equal to $4. So if that's the individual cost of 1 burger and 1 fry, then what is the cost in dollars of 2 burgers and 3 fries? Well, that's 2 times 4 plus 3 times 3, which gives us $17. So our final answer would be $17. Now here it is in money, but again, you don't need to put that as your unit. All you have to put in the box is your numerical part of the answer. Now, again, here is our thinking process. I know it's not the most neat handwriting, but bear with me. Now let's move on to 5D. Nicholas has 60 inches of wire that he will use to create the edges of a cube with the greatest possible volume. What is the volume of that cube in cubic inches? To accomplish this, the wire will have to be cut into several pieces. Okay, so the first thing that I want to clarify about this question, it added another piece of information to trick you on purpose, to make you think more than you need to. It said to create the edges of a cube with the greatest possible volume. We don't need to hear that, because there is only one cube that you can make with 60 inches of wire. There's no smaller version or bigger version, so it doesn't make sense to say the greatest possible volume, because there is only one volume that you can create as a cube with 60 inches of wire. Now that is out of the way, all we have to do is solve. So after that, there's much less thinking you have to do. The edges of a cube are all equal. And how many edges are there? Well, there's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So 12. What we're going to do is divide 60 into 12 equal pieces, which gives us 5, meaning that each edge is 5 inches long. Now, if each edge is 5 inches long, what would be its volume? Well, that would be 5 times 5 times 5, which is equal to 5 times 5 times 5, which is equal to 125. So what is that volume? That would be 125 inches cubed. But since this is a contest and it does not require your unit, I'm just going to write 125. Okay, so that is our fourth question. Pretty simple, right? Let me put that off to the side, and we can move on to our last question. 5E. The Elementary School Bowl is a tournament where all the schools play each other exactly once. Springfield Elementary School is one of the schools in the tournament. If there are a total of 28 games in the tournament, how many games does Springfield Elementary School play? So here I'm going to draw a line, and on it I'm going to draw some more points. Each of these points is going to represent another school. For example, here is A, B, C, D, and E. Let's start with 5 schools first, and we can call this school, A here, Springfield Elementary School. So this is Springfield Elementary School. Now I'm going to connect 2 points every single time they play a game against each other. Since each school has to play every other school exactly once, it's going to look something like this. A against B, A versus C, A versus D, and A versus E. So that's already 4 right there. Let's keep track of how many games we play. Now we start with B. Well, do we have to go back and connect B with A? No, because they already played a game. So we could just do B and C, B and D, B and E. So after this, that would be 3 more arcs. CD, CE, we connect those. We have 2 more, and then DE. which is 1 more. Added together, this is equal to 10. But we're trying to get it so that it adds up to 28, which means we have to add more schools. But what's the pattern you notice right now? We notice that when there are 5 schools, we always start with 4 and then we add 3 to 1, which tells us that if we were to add another school, say F, now that we have 6 schools, we're going to have to add another 5. So 5 plus 10 is equal to 15. How can we add more schools so that 15 becomes 28? Well, let's see. We're going to have to add another 6, which gives us 21, and then add another 7, which gives us 28. And according to our pattern, since out of all of these add-ins, 7 is the greatest, and we still have to add 1 to that to show the number of schools there are, since the number of schools is always greater by 1 than the greatest add-in, so that would be 8 schools. So 1, 2, 3, 4, 5, 6, 7, 8 more schools. So we have 8 schools here. But what's the question asking for? It's asking for how many games does Springfield Elementary School play? If Springfield plays, we already know that they play 4 games in here. Well, 5, 6, and then we have 7. So since each school needs to play every other school exactly once, Springfield Elementary School will have to play 7 games.